In this video, we're going to be going over some basic exponent examples. We'll be working through the 6 examples that you see on the slide here. The key to these is attention to detail and going one step at a time. So I will be showing my work. I encourage you to do the same as you're writing these down in your notes and as you're working through problems on your own. So let's go ahead and get started with the first one. I think it's a good idea, especially when starting out, to put an exponent on anything that you see that does not have an exponent on it. So if there's not an exponent, there's an implied exponent of 1. So I'll go ahead and put a 1 on each of those 3's. And we can go ahead and apply our exponent rules now. So with my v's, I've got a v to the 0th power. Actually, let's go ahead and take care of that guy real quick. Anything to the 0th power is equal to 1. So really what we've got going on here is a 3 times 1 times 3v squared. And at this point, you know what, I might just go ahead and multiply the 3 and the 1 and the 3 out. 3 times 1 times 3 is going to give us 9v squared. And at this point, we're actually finished. We're finished. That's as far as we can go. There's nothing else that can be combined together or simplified. So 9v squared. Perfect. Moving on to the next example. All right, so let's do the same thing that we did before. Let's go ahead and put a 1 on this on this base that doesn't have an exponent on it. And let's see what we got. Now I've got parentheses here with an exponent on the outside. So I'm going to go ahead and deal with the parentheses. What that means is that we're going to apply this power of 2 to everything inside the parentheses. And since we've got power to a power, we will be multiplying the exponents. That's the rule. So 1 times 2 is going to give us 2, and 3 times 2 is going to give us 6. All right, so now what can we do here? The bases are not the same, so there's nothing we can combine. I guess our last step is going to go ahead and simplify that 3 squared. It's called 9. 9n to the 6th, and that's as far as we can go with that one. Okay, something similar going on in this. I'm going to go ahead and throw some exponents onto that 3 and the x that don't have them. And let's take care first of the parentheses. So we've got a power on the outside. We need to multiply that exponent of 3 here with all the exponents on the inside. So we're going to have x to the, let's see, 2 times 3 is 6, times 3, exponents are 1, times 3 is 3, times x to the 1 times 3 is 3. I might go ahead and rearrange these terms and put the 3 to the 3rd out in front. Remember, when you're multiplying, you can always multiply in any order that you like to. 3 to the 3rd is 3 times 3 times 3, that's 27. And I've got an x to the 6th and x to the 3rd. Since the bases are the same when we're multiplying those things together, we should be adding the exponents. 6 plus 3 gives us 9. There's nothing more to be done here, so 27x to the 9th will be our final answer. Next example. We've got parentheses that I'm going to take care of first, but let's go ahead and throw some exponents onto those bases without them. So I'm going to leave the x alone for right now, x to the 1st. Let's take care of this parentheses and this power on the outside. I've got a 3 out there. It's going to need to multiply by our 2 exponents on the inside. So we're going to have 2 to the 1 times 3 is 3. We're going to have x to the 2 times 3 is 6. So at this point, we could rearrange. Actually, let's go ahead and deal with the x to the 1st and the x to the 6th. They are being multiplied. We can multiply in any order we want. So we could multiply those two things first. Since the bases are the same and we're multiplying, we are going to end up with adding the exponents. 1 plus 6 is 7. So that takes care of those. And then the only thing that we didn't take care of was our 2 to the 3rd. Now that's 2 times 2 times 2, which is 8. So we've got 8x to the 7th, and I believe that's as far as we can go with that one. All right, this one we've got a fraction. We've got 5r to the 4th over 3r. And we need to try and simplify this as much as we can. Now, I'm looking at this 5 and this 3 and asking myself, does that fraction reduce at all? 5 over 3 does not. So I'm pretty sure our final answer is going to have a 5 and a 3 in it. We've got r to the 4th over r. Now, r to the 4th is really r times r times r times r. And we've got a single r on the bottom. Normally, I wouldn't write this out. I just kind of envision this in my head. But you can see that if I were to cancel these two r's, we would be left with 3 r's on the top. That's 5r to the 3rd power. And there are no r's left over on the bottom. It would just be a 3. So this step here, I probably normally would not write out. This is my little thought bubble. I would do that in my head. And then note that 5 over 3 does not reduce, so that's going to be our final answer. Okay, last one for this video, and then the next video you'll see some more advanced examples. A lot like the last problem, I'd probably start by looking at this 2 over 4. Note that that does actually simplify that into 1/2. So in my final answer here, I expect to see a 1 on the top and a 2 on the bottom. Now, probably that 1 might go away, might not. Let's see what happens here. Kind of like the last example, I'm going to sort of envision in my head a squared as a times a, and a to the 5th is a times a times a times a times a. And we can do some canceling here. We've got some a's that we cancel top and bottom. All the a's are gone away on the top at this point. So we don't have anything left on the top but that 1. And on the bottom we've got a 2 and a times a, which I would write as a cubed. And there's nothing else to simplify, so that's as far as we can go, and that will be our final answer. In the next video, you'll see some more involved, more advanced problems involving exponents.